Today we'll discuss module 3, that is operational amplifier. So basically amplifier means it's a circuit that amplifies the input signal. Say we are giving input as 2 volts, means it has to produce output as more than 2 volts, say 3 or 4 volts. Okay. So operational amplifier, basically it will amplify the input signal. And first we'll start with the circuit diagram. Right. So this is the basic diagram for operational amplifier. And for this we can give two inputs. Suppose if you are giving input to pin number 2, means we need to call it as inverting input. If you are giving input to pin number 3, means it is called as non inverting input, and output we are taking from pin number 6. And for this IC we need to provide two types of supply. One is positive supply, it has to be given to pin number 7, then negative supply to pin number 4. For pin number 7, whatever the supply we are giving, we are calling it as plus VCC, and the range varies from say 12 to 15 volts. And for pin number 4 we need to give the negative supply, that is minus VEE, and the range varies from minus 12 to minus 15 volts. Okay. So next is, we have two types of amplifiers. First one is inverting amplifier. Inverting amplifiers. So how it works is, this is ground. See, inverting amplifier means whatever the input we are giving, we need to give it to pin number 2, and at the same time we need to ground the pin number 3, that is non-inverting terminal. And input, say it's a sine wave, CVI, and say it is 2 volts. Okay, and 2 volts it is the peak voltage. 2 volts it is the peak voltage. And if we consider from negative peak to positive peak, it will become 2 plus 2, that is 4 volts. Okay, and from origin to positive peak is considered as plus 2 volts. And output side I can expect like this, means whatever the output we are getting at the output side, it is inverted as well as amplified one. Okay, so this is amplified as well as inverted compared to the input voltage. So this is about this is the output that we need to get from pin number 6. But the thing is, in case of inverting amplifier, what we are doing is we are giving input voltage at pin number 2. At the same time we need to ground the non-inverting terminal, and we need to take the output from pin number 6. This is in case of inverting amplifier. And now we'll see what happens in case of non-inverting non-inverting amplifier. Okay, so first we need to draw the diagram or circuit diagram for non-inverting amplifier. So in case of non-inverting terminal, what we are doing is we are giving input voltage. We are giving input voltage to pin number 3. Means we need to ground the inverting terminal. Okay, and output again it has to be taken from pin number 6. Say this is input voltage Vi. Again say it is 2 volts. That is the uh, voltage, or amplitude is 2 volts, right? And how we need to get the output? In this case, V naught should be non-inverted, and at the same time it has to be amplified one. So if we compare the outputs of both inverting and non-inverting amplifier, we can conclude that in case of inverting amplifier, whatever the output you are getting, that is inverted as well as amplified. But in case of non-inverting amplifier, whatever the output we are getting, that will be in phase with the input, and at the same time it is amplified one. Okay, so next we'll see the pin diagram of this op-amp. So whatever the IC we are using, that is MUA 741, it is the IC of our op-amp. It has got 8 pins. 741 IC, pin number 1, 2, 3, 4, 5, 6, 7, 8. Okay. Out of 8 pins, pin number 1 and 5 we are using for offset offset null. That we'll see later. What do you mean by offset null and all? And pin number 2, so it is inverting input. Pin number 3, non-inverting input. Pin number 4, supply. Number 6 is output. Again, pin number 4 is supply. Number 7 is supply. Pin number 8 is not applicable, means we are not using pin number 8. Okay, so next is that comes ideal op amp. What do you mean by ideal op amp? Basically we have two types of op amps. One is ideal one is practical op amp. Say I have an op amp, right? I can give the inputs in two ways, means either to pin number 2 or pin number 3. Say I am giving 2 volts to pin number 2 and again same 2 volts to pin number 3, and I can expect output from pin number 6. So I have one formula, V naught equal to A into Vt. This is the basic formula that we are using in case of that we can use to calculate the output voltage in case of op amp. So V naught is output voltage that we are checking at pin number 6. A means it is open loop gain. A means it is open loop gain. Gain means where we can take the ratio of output by input. It has to be more than 1. And Vd means it is the difference between two inputs. Okay, so we have this formula, V naught equal to A into Vd. Okay, so in this diagram I have given two inputs as 2 volts. So if I use the above formula, V naught equal to A into Vd. Okay, so A into Vd means say it is V2 minus V1. So this is V1, this is V2. So if I use that formula, I need to get put as 2 minus, this is minus, this is, so 2 means I need to get output as 0 volt. But what happens is in case of practical op amp, I cannot expect the same 0 volt. But whatever the 0 volt we are showing over here, this is with respect to the ideal op amp.